Yeah, good evening, dear students. Welcome to my session on solid state, particularly it is classification of solids. As we all know that there is much importance is given to the classification of solids. In that particular classification, we have two important things are there. Two important types of classification of solids are there. They are crystalline solids and amorphous solids. So one is called as crystalline solids. The other one we will call it as pseudo solids or amorphous solids. Amorphous solids, or we can also call they are pseudo solids. Pseudo solids. Let us talk about the crystalline solids. Now, let us talk about crystalline solids. What is the meaning of crystalline solid is? A systematic arrangement is the meaning of this crystalline solids. So, what are systematically arranged? The question definitely arises. The systematic arrangement will be noticed in the case of crystalline solids for their constant particles or constituent units. So one word we will use constituent unit. The constant unit may be atom, constant unit may be molecule or ion, anything that may be atom or that may be ion or that may be a molecule, or simply we can call it as is a particle. Is a particle. Unit is nothing but a particle. So in this crystalline solids, constant units are said to be arranged in a orderly fashion. Constant units arranged in orderly fashion. What is orderly fashion? Means systematic arrangement. The systematic arrangement of these constant particles in the solids called crystalline solids will be noticed over a long distance. Over a long distance. And actually this distance is also said to be compared with the interatomic distances. It is more. That means atom distance is how much is there. More than that, the systematic arrangement is noticed in a kind of solids called as crystalline solids. For example, you all know there is a common example for everybody knows sodium chloride. If you take sodium chloride, crystalline sodium chloride, when you take sodium chloride consists of Na plus and Cl minus ions are constant particles, and they are located in the arrangement alternatively. Na plus and Cl minus are located alternatively like this. Na plus Cl minus, Na plus Cl minus, Na plus Cl minus like this. Again here when you start from here, it will be Cl minus, Na plus, Cl minus, Na plus, Cl minus, Na plus. Here Na plus, Cl minus, Na plus, Cl minus, Na plus, Cl minus. Here it will be Cl minus, Na plus, Cl minus, Na plus, Cl minus, Na plus. If you see this one, the arrangement shown here actually is a two-dimensional two-dimensional arrangement. What kind of arrangement it is called as? Two-dimensional arrangement. And the location of this Na plus is called as the site. Location is also called as site. This is Na plus site. This is Cl minus site. Alternative sites are there in this two-dimensional arrangement, very comfortably arranged and noticed. And actually each Na plus ion is said to be in this arrangement surrounded by, there are 6 Cl minus ions. One Na plus is said to be surrounded by 6 Cl minus ions. Okay. So what is this arrangement? That arrangement cannot be noticed in this one. That's why in three-dimensional arrangement only we can understand what is the kind of ions surrounded by one particular ion which are oppositely signed. Okay. That similar regular arrangement is also found in other solids. For example, if you take Na plus in three-dimensional fashion, what is the coordination? Here Na plus is there, here Cl minus, 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 here Cl minus. Similarly, when you consider Cl minus ions, around that Cl minus ion also 6 Na plus ions are possible. That means how many Na plus ions are surrounded by one Cl minus ion, and how many Cl minus ions are surrounded by one Na plus ion. If you see, that kind of arrangement is called as three-dimensional arrangement. And similar regular arrangement is observed in all the different kinds of crystalline solids like diamond, sugar, quartz, etc. etc. Okay. So that constant particles in NaCl are Na plus and Cl minus ions in a crystalline solid. Why they are arranged systematically? The answer is nothing but actually they are held together by strong electrostatic force of attraction. What is this force of attraction between this Na plus and Cl minus in NaCl crystalline solid is electrostatic force of attraction. Electrostatic force of attraction. So you can understand the force of attraction between the constant particles in crystalline solids is responsible for the order arrangement, systematic orderly arrangement of that particles. That is actually strongly holding the particles together. Therefore, when you consider constant particles of crystalline solid, they don't have any kind of translatory motion. Just they will vibrate in the equilibrium positions only. That's why the vibrational motion is there, but translatory motion is not there. That is the characteristic feature of crystalline solids which is noticed in the NaCl, diamond, sugar and other three-dimensional network substances. This is what we notice, that crystalline solids are said to be definitely are having a particular geometry. What is the most important characteristic property of crystalline solids are nothing but they have a particular geometry is there. Definite geometry is there. Definite geometry is there. In this crystalline solids, a definite geometry and also particular geometry for some of the solids definitely extend through the crystal, and that is why this is said to be extended and that extension of this definite geometry in the crystalline solids is making their long range ordered particles. That means crystalline solids are having constant particles arranged long range ordered constant units or particles. So this is the most important characteristic property of crystalline solids, we can say. So what is the most important characteristic property of crystalline solids is crystalline solids are having definite geometry, and that geometry is said to be extended a long distance when compared to the distance between the constant particles. That means interatomic distance, we can say. Another thing, when you talk about melting points, the characteristic properties of crystalline solids, when you are observing, when you just check the melting point of a crystalline solid, exactly, that means the sharp melting points will be given by crystalline solids. So they have sharp, or they show, we can simply call, they show sharp melting points. That means exactly at a particular temperature the solid starts converting into liquid state. Another important thing is there in the crystalline solids, we notice that is anisotropic. They are anisotropic in nature. They are anisotropic in nature. What is the meaning of this crucial technical word? Is nothing but the physical properties are there for crystalline solids. For example, if you take thermal conductivity, electrical conductivity, or refractive index values, these values are said to be exhibited by these crystalline solids in different directions. They will exhibit different values. So the meaning is nothing but different values of physical properties in different directions in crystal. So this is the most important technical word we have to prepare carefully, because anisotropic and isotropic natures are said to be the study of the physical properties in the different directions of the solids. In such a case, in different directions of the solid, the physical states like physical properties like the refractive index values, electrical conductivity values and all for crystalline solids are noticed as the different values. Whereas when you just observe the amorphous solids, these values are said to be noticed in a similar manner. That means they have similar values of the physical properties noticed in all directions. That is known as isotropic nature. So isotropic nature is exhibited by amorphous solids. Anisotropic nature is exhibited by crystalline solids. Okay. So that kind of direction, that means a physical property, if you observe a crystalline solid, physical property value of a refractive index value in one direction will be saying A. In another direction, if you see the refractive index value, if you say it is B, those values are not same in the case of crystalline solids. Whereas these values are same in a case of amorphous solids. Likewise, thermal conductivity, electrical conductivity values, and some of the physical properties when you just study interior of the solids, the physical properties are definitely different for crystalline solids and they are same for the amorphous solids. That is the most important kind of characteristic property of crystalline solids we can understand. Another thing, when we are talking about crystalline solids, we should speak about another important characteristic property of a solid. That important characteristic property we can call cleavage property. Cleavage property. When you talk about cleavage property, what is the meaning of cleavage? Just cutting, breaking of a substance. Now in the case of solids, cleavage is property that is noticed differently for crystalline solids and amorphous solids. That means when you cut a solid, particularly crystalline solids, what will happen? When you cut with a sharp edged tool, when you take a tool, sharp edged tool, what will happen? Crystalline solids will give two pieces. Cleavage means breaking two pieces with planar surfaces. When you cut with a sharp edged tool, they make two pieces of plane surfaces. Plane surfaces. We can say planar surfaces. That means when you cut a crystalline solid with a sharp edged tool, what will happen? Then two pieces are noticed, then the two pieces definitely will have planar surfaces. Suppose when you take any kind of solid, if you cut that solid, surface will be planar surface. That is the face of the crystal. Face of the crystal surface. And that is actually another important, most important characteristic property of crystalline solids. Not only that one, we have a most important property of crystalline solids are there, that is called as symmetry. Symmetry. So now I am rotating like this. That means when I rotated along an axis by considering an imaginary axis, my position in whichever direction I rotated, whichever the angle, I should look like similar manner. That is called as a symmetrical way of observation. That means crystalline solids will exhibit that kind of thing. Okay. But if you are not observing such kind of things, then that is called as unsymmetrical property of solid. Now in the case of crystalline solids, the crystalline solids are said to be exhibiting symmetry. That means when a crystalline solid is rotated about an axis, definitely it will appear, it does not change. It remains in the same manner. That means whatever the direction if you rotate, that looks similar. Similarity in the appearance of a solid when you rotate that solid along a particular axis. What is similarity? Is symmetry. Similarity in the appearance. Similarity in the appearance of a solid when you rotate along an axis about some angle. So, rotation also takes place with some extent of angle. Angle of rotation is very important. Rotation means we are changing the angle of the face of the crystal. So when you change the angle of the face of the crystal by rotation, when it looks similar, that is called as symmetrical symmetry. So crystalline solids exhibits an important property called as symmetry. So the symmetry may be of different kinds, we will discuss later on. So this is the most important property I can say for the crystalline solids. Now talking about the second important characteristic property classification of solid, amorphous solids, also known as pseudo solids. Hope you understand crystalline solids properties, crystalline solids meaning, what is crystalline meaning, and how can we see a crystalline substance when it is in a two-dimensional or in a three-dimensional. It's in a three-dimensional manner. If you see the crystalline solids, definitely we will be having a complete clarity about the interior parts of the crystal. So that is observed, and we have noticed that the different geometry is exhibited, and long range order arrangement is noticed in the crystalline solids, and they exhibit sharp melting points, whereas anisotropic nature is also important property. Cleavage property of crystalline solids is noticed, and symmetry is also most important characteristic property of crystalline solids. Let us discuss about the second one, amorphous solids. Amorphous solids. Another name for these solids is pseudo solids. Another name for this one is pseudo solids. In the name itself, we are specifying that these are quite opposite to that of crystalline solids, because these are not perfect crystals. These are not perfect crystalline solids. Means when you are talking about the arrangement of the constant particles like atoms, ions or molecules, the systematic arrangement is not said to be noticed in this case. Lack of order arrangement of constant particles is in the amorphous solids will be noticed. And a characteristic property of solids definitely rigidity and resistance to change the shape against the mild distorting forces. So what is the property of this kind of solids is nothing but mild distorting forces. If you observe, if you just apply, definitely rigidity and resistance to change the shape will be noticed for this kind of solids. Take an example, best example and easy example for understanding, that is if you take a rubber and try to stretch it and bend it and again just release the force, what you will notice is that will try to oppose that kind of a change in the shape, that is called as rigidity. So however, these kind of solids are this type of solids which lack this property. They are amorphous solids. They are easily distorted by bending or compressing forces. Okay. So they are amorphous solids. So talking about rubber is the best example for amorphous solid. The distorting forces when you apply over that one, definitely the distortion can be noticed when you just try to apply that force on the solid. On long standing, what will happen? If you just keep the rubber like this for long standing without leaving, it will definitely lose its shape, and also the flow under own weight. Okay. So what will happen? That kind of solids are said to be pseudo solids or amorphous solids. So flow of the particles definitely changes, and as well as the shape of the solids also changes. If you take glass, starch, proteins, rubber, plastics are the best examples for this one. Glass, starch, proteins, rubber, plastics, etc. etc. These all comes under this kind of category, and some common examples when you see, the common examples are glass, starch, proteins, rubber, plastics, pitch. These are different kinds of names are there. They are comes under pseudo solids or amorphous solids. And now talking about this rigidity or the shape of the changing in the shape of solids, only apparent such substances actually supercooled liquids. For example, such substances are also called as supercooled liquids. The another synonym or name of this kind of solids is nothing but supercooled liquids. On heating, what will happen? These kind of pseudo solids gradually soften over a wide range of temperature and before they actually changing into liquid form. Understand what is the meaning of this one is nothing but when you start heating the solid definitely starts getting melting at one particular temperature. But this kind of melting process will be noticed over a wide range of temperatures in a case of amorphous solids. So they don't exhibit any kind of sharp melting points, and that kind of process takes place over a wide range for this kind of amorphous solids. So these solids are gradually softened, and that is nothing but they are not said to be perfect solids. They are said to be pseudo solids. When you heat or cool slowly, what will happen? Amorphous solids definitely becomes a systematic way of arrangement called crystalline solids. Okay, crystalline at some temperature, that too particularly crystalline at some temperature, and because the reason is very clear that glass particles of ancient time, the articles at ancient time over a wide range, what they used to do is look milky due to some crystallization having taken place. So when crystallization is taking place slowly, if you heat that substance, that looks like turbid inside, that is amorphous solid in the study of the application of temperature. Now coming to the point, constant units, how they are arranged. Let us see constituent units. When I talk about constant units in crystalline solids, they have a systematic arrangement, orderly fashion arrangement, long range ordered arrangement noticed. But it does not possess, these constant particles does not possess any order arrangement over a long range. Constant particles does not possess order. What kind of order it is? Long range order arrangement. Simply we can say it is a short range arrangement. Simply we can say they will arrange in a short range manner, short range ordered, short range ordered in the amorphous solids. Whereas when you talk about long range ordered, that means that long distances the systematic arrangement is there, crystalline solids. short distance arrangement is there, that is called as amorphous solids. That means there is no such kind of systematic arrangement is noticed in amorphous solids. Okay, and moreover, the orderly arrangement is then why it is restricted is nothing but magnitude is in the between the constant particles. The force of magnitude is not perfectly noticed. That means the interatomic or forces, inter-attractive forces, intermolecular forces are irregularly noticed in the case of amorphous solids. Okay. What are crystalline? What are non-crystalline? Now we are observing in this one. That means magnitude of interatomic whatever distances is there, that magnitude of interatomic distances is quite different or irregular in the case of amorphous solids. Sometimes what will happen? A small part of the amorphous solid definitely will behave like a crystalline solid, and the rest of the other part will behave like a non-crystalline solid. So what is the meaning of this short range arrangement is a small part arrangement arranged like crystalline, and rest of the portion we can say arranged like non-crystalline. So the meaning of short range order is this one only. So small portion in the amorphous solid behaves like a crystalline solid, and rest of the portion is behaves like a non-crystalline solid. So crystalline part is nothing but, otherwise amorphous solids is also called as crystalline. So if the case is continued, amorphous solids also will become crystalline solids. So that means the systematic manner of manufacturing a solid by the application of cooling will give crystalline solid. Sudden cooling will give amorphous solid. That means amorphous solids, when you start heating and again when you just make them cool in a gradual manner, definitely they will convert into amorphous solids. So that is the meaning of the amorphous solid is nothing but a classification of solid. Talking about amorphous solids, important characteristic properties. Amorphous solids definitely don't have any kind of definite geometry. They do not have definite geometry. Whereas a definite geometry is noticed in the case of crystalline solids. And almost we can observe amorphous solids are there. Their melting points, when you see, they will melt over a wide range of temperature. That means they do not exhibit sharp melting points. That means they will melt over a wide range of temperature. That is the case of amorphous solids. When I come to the discussion about isotropy and anisotropy, amorphous solids are said to be isotropic in nature. Isotropic in nature. So the properties, if you see, properties like conductivity, mechanical strength, all these things for the amorphous solids are said to be noticed the same values in different directions. So property of physical property of any kind of solids, either crystalline or amorphous solids, if that physical property value is coming similar in all the different directions, then that is noticed as amorphous solid. That is the characteristic property of amorphous solid is isotropic nature. Another one. When you talking about cleavage property, cleavage. So when you are talking about cleavage property, when you talk about the cleavage property of crystalline solids, they are cut into two pieces, and also surfaces, soft surfaces, planar surfaces we noticed. But in a case of amorphous solids, if you see the cleavage property, amorphous solid on being cut with a sharp edged tool, what will happen? It also gives two pieces. But the surface is not said to be the soft surface, planar surface. That means irregular surfaces noticed when we cut with a sharp edged tool. So blade or anything if you take, if you cut the surface or cut the amorphous solid rubber, if you cut it, the surface is not said to be a planar surface. The surface is irregular surface. The face of that part of the cut part of the solid is not said to be the planar one. That is a important property of amorphous solids when you compare with the crystalline solids. Talking about the solid symmetrical property, as we have discussed about the symmetrical property, symmetry of the crystalline solids. Crystalline solids exhibit symmetry. So quite opposite to the crystalline solids, these are amorphous solids. So they don't have any kind of crystal of symmetry. They do not have crystal symmetry property. Crystal symmetry means amorphous crystals if you take, amorphous solids if you take, they don't exhibit that systematic manner of the repetition of the appearance along a particular axis. The rotation of the solid along an axis won't give any kind of similar appearance in this type of amorphous solids. So amorphous solids don't exhibit the symmetry property, whereas crystalline solids exhibit symmetry property. Hope you observed the two important classification of solids, crystalline solids and amorphous solids you observed, and this crystalline and amorphous solids differences asked in the examination. Most particularly you will give the examples, and after that you will give the constant units arrangement, constant particles arrangement. You will give melting points, how they are present for both crystalline and amorphous solids, whereas the isotropic and anisotropic nature differences and cleavage property, these things you can just discuss in the question between the differences between the crystalline and amorphous solids. The main points of this crystalline and amorphous solid discussion we have done in this session. Particularly, this is a theoretical aspect. Even though it is a theoretical aspect, it is the most important question for the examination point of view. In the short coming session, we are going to talk about crystalline solids and their details very clearly. How the crystalline solids are classified on the basis of different kinds of bond types in them in details with examples, and with what kind of forces of attractions make them that type of broad classification with examples, as well as the properties of that crystalline solids classification, as well as constant particles types also we will see in that next session. Until have a nice day. Thank you very much.